All right, greetings, fellow grade 10s. It's Mr. Shatra again. You look now, we're back again. We are still looking at our probability, right? Now, I want us to attempt these following questions and see in terms of what is it that we can do there. Now, let's start here. Now, they say in a random physical science experiment, A and B are two events, right, or are two different events. It was found that the probability of A, it is given by 2 over 5. The probability of not B, remember there is this thing here, which means this is the probability of not B. It is 3 over 8. And the probability of A or B, it is given by 5 over what? 5 over 7. Now, the first thing they want you to calculate what is the probability of B. Now, from there, now from here, what is it that I want you to take note of? You know that if you are having the probability of B and probability of not B are complementary event. Probability of B plus the probability of not B. Those are going to be complementary events, and complementary events are events that add up to 1, right? So which means if you are having probability of not B, you can be in a position to calculate the probability of B. This is what you are going to do. You're going to say, look, now the probability of what? The probability of B now is going to be equals to 1 subtract what was the probability of not B? It was given by 3 over 8, right? And now when you plug that in calculator, you say 1 subtract 3 over 8 and see in terms of what you're going to find. The answer that you're going to find that this is 5 over 8, right? This is going to be given by 5 over 8. Now that is going to be your probability of B. So then this is your 2 marks of probability of B. Now the second one is, now they want you to find what is going to be probability of A and B. You know, on a simplest, no format of writing this. Basically, when they want you to calculate the probability of A and B, they want you to prove whether is there an intersection. Right, let's start there. They want you to prove that is there an intersection. And how do you prove whether there is an intersection? You prove the intersection by determining or by finding out whether is this going to be mutually inclusive or mutually exclusive, right? You are going to start by now look using the formula of this, your probability of A or B, which is equals to the probability of A plus the probability of B plus the probability of B, subtract the probability of A and your B, right? This is basically the formula that you're going to use now to find out what is the probability of A and B. So basically, it's more like you're proving the inclusivity, right? And then now, if you come in here, what is going to be your probability of A or B? Probability of A or B, you are given that this is same as 5 over 7. So you come and substitute the 5 over 7. Then it is going to be equals to what is the probability of A? The probability of A, you are given that this is 2 over what? 2 over 5 plus the probability of B plus the probability of B, and the probability of B that you're going to find there, it's the one that you've calculated, which is 5 over 8. Subtract your probability of A and your B, right? This is going to be what you are doing. And then after that, you are then going to say, look, you are going to take this probability of A and B, transpose it this side and take this value this side, right? So which means you're going to say this is same as probability of now A and B. Probability of A and B, it's going to be 2 over 5 plus 5 over 8, subtract what? Subtract 5 over 7. And the answer then that you are going to find after you have done that, it is going to be given by what? Let's punch in our calculator and see in terms of what is the answer that you're going to get. All right, so when you punch in your calculator, now this is going to be what you're going to find. This is, let's see. Now the answer that you're going to find is 5 over 8, basically, right? The answer that you're going to find, it's going to be 87. This is going to be 87 over 280, right? Then which is same as what? 0,31. So this is going to be a probability of A and B. Right now, let's look at now the second question. Now, the second question already now they say hence or determine. So basically they say using the answer that you got above, determine whether event A or B are mutually inclusive or mutually exclusive. So these, are they going to be mutually exclusive? No. Remember, for mutually exclusive, if I can represent this in your Venn diagram, right? Mutually exclusive is going to be those particular cycles which do not have what? Which do not have what? The intersection here. So which means they do not have the probability of what? Of A and your B, which means the probability of A and B is equal to 0. But in this case, it's not going to be the case, because you are going to have no, because now look, now what is it that we know? No, they are not mutually exclusive. Why are we saying so? Because look, the probability of A and your probability of A and what? And your B, it is given by what? It is given by a value, which means it is not equals to 0. Right? And for mutually exclusive, they must be equal to 0 here, because there is no intersection. So this means they are mutually inclusive, right? Are we together? Then now let's then continue and look at your 8.2.1. Now in 8.2.1, they say, I write down the probability of each of the shade region for each of the following diagram. Now this one, now remember, we said now, if you are having the shading in here, this shading here, the shading here means an intersection. This means intersection, right? This means look at me writing my thing here. It means intersection, right? And what do we know about intersection? Which means there is inclusion. So this is basically a probability of A and your B, right? Because there is an inclusion. Whereas now this is going to be a probability of what? Look, you're having A and you're having B. And which means now, because they've shaded the outside structure, so this is going to be what now? Which means they are looking for everything except for A and B. So which means this is going to be a probability of A or B not, right? Because they are not looking for the probability of A and B. They are looking for everything that lies outside the probability of A and B, right? So it's going to be a probability of A or B not. Whereas now here, if you look at this one, now in this case, they want what? Here in this one, they want the probability of A. Can you see that the shaded part is the one that is your intersection, or the one that is not shaded is the intersection? So basically, they say probability of A and what? And B not, because they are looking for everything except for this part, which is your intersection, right? Then it's going to be now the probability of A and B naught. And now the first one, now the last question, they say now which diagram or diagrams in 8.2.1 represent mutually exclusive, mutually exclusive. Now, which means, remember, we are saying for mutually exclusive, no intersection, no intersection. And now if you can check which question now was probably providing or rather was giving us no intersection, it is this one. Remember, because the part that is in here, can you see this part is not shaded, right? So which means this is going to be what? The answer for your 8.3 is going to be what? 8.2.3, which means it is going to be basically this question that they are asking for in here, right? Now, hopefully now this makes sense to you. Thank you very much.